Chris, you can start.
Okay, great. So thank you, Lev, for the opportunity to share something that's kind of a passion of mine. I was exposed to Graphviz and dot language for generating diagrams with code from a coworker in a previous job, and I still am not where he is. He generates his documentation, code documentation, using dot right within his code. So whenever he makes a code change, when he submits a PR, all the diagrams for all the resources are updated. That's a dream for me. I'm trying to get myself there. He works in Java and Scala, so it might be related to that. I don't know. I'm working with Python, and I'll show you a little bit of Python code to generate graphs as we go along. So the idea here is, why do we create diagrams? Let's start there. It's like, so we create diagrams for collaboration. So if I was to give code to Lev or to Irina, if I send them a diagram, they understand the code better. If I send a ERD diagram to Tyler, he understands the data structure. And so it's really helpful in collaboration. It's also really helpful in defining a clear vision. There's oftentimes when I start creating a diagram, I recognize that, oh, I forgot a step, or there's a little more nuance than I thought there was. And so that kind of also tags into that identifying shortcomings. But if I can diagram what I'm trying to do, then I have a clear vision of where I'm headed. It's also great for communicating. So if I was to create a diagram, say a flowchart diagram for the business, I can say, here's how the code is going to work. And this is what we're doing. We're going to go A to B to C to D. And they get the idea of what's happening. And then, of course, ultimately, it's great for documentation. So when I'm gone, someone else can pick up the code. They can look at a diagram and go, oh, I understand what's happening. So these are the reasons why we would create a diagram. So then we, various different types of diagrams, they're examples of our database ERD, a UML showing the classes and the entities within the classes and how they interact with each other. There are flow charts. So here's, flow chart of processes, creating wireframes of applications. So here's my web page. I'm going to create a diagram that shows the wireframes of the website, right? And data flow. It's also, there's another classic diagram methodology is doing a data flow. Here's the data comes in here. These ETL processes happen, and now we get to this end result. And then also architecture. We draw architectural diagrams. So what is a diagram look like for a Google Cloud instance, for example. So that's another type of diagram that we would create. Now, there's lots of different diagramming solutions. The top ones are Microsoft Visio and Lucidchart, but there's also Draw.io and Miro, and there's various other different versions of these. But the thing that I found the most frustrating is they're kind of a pain in the neck to deal with. So you drag an object onto a page, and then you click and you add. You have to hand type, and if it's right in the right spot, then everything works great. If it's not in the right spot, then you got to figure out where it goes, and you're constrained by the software itself. And so I find that I get so frustrated using these tools. Like, can I just type in what I want it to look like and have it work? So there is another way, and the diagram is code. And there's a number of different solutions out there for doing this. But the one that I use is dot. It's the dot language, and using Graphviz as the renderer for that. The dot language was a Bell Labs project. I say another Bell Labs project. If you go and look at Bell Labs in their history of what they've actually put into the world, there's a lot of different things that they do, and dot was one of those things. And there are now Graphviz actually renders a significantly a larger number of engines. So there's Nito and some other engines like that. But I find the dot serves most of my needs, and it's pretty straightforward and simple. So why would you diagram with code? It's like I said, it's simple. You don't have to drag and click. You don't have to make sure that your dots are going to the right spot. You can just code it out. That's one of the reasons. Version control. So yes, you can version control your diagrams, but what you version control typically is actually a picture, an image, right? Well, images can get large, the larger and larger your diagram gets. So when you put an image into version control, now you've got these blobs that get bigger and bigger, and they're not as efficient. So then we get to the efficiency, right? So if I make a single change, so a one-line change to my code that's generating my diagram, now that code in Git, say we're using Git for version control, that change is really small. And I can actually diagram with dot, and I'll show it. I think I have a demonstration of that. That when I'm sitting on a webinar and they're talking about data, say data flow, I can actually generate the data flow as they're talking. Try doing that with with Visio. Try doing that with Lucidchart, right? You'll get lost, you'll get left behind. So I'll just pop open a dot file, and I'll just start coding away and creating my diagrams. So it's pretty efficient, and I will get into what does it look like. So this is this simple code generates a diagram, and so this is the general structure of the code. It's not exactly a YAML file. There's really some very loose rules about what the code looks like, as far as indenting, as far as capitalization, where things lie in the process. The one thing to recognize, and one thing that's most important to know, is it delivers it in the reverse order that you see it on the page. And right now, this is just a bunch of edges. So then the nodes are just basic, straightforward nodes. So it's hard to see this, but I'll show you as we get further through the process. I'll show you what I mean by it does it in the reverse order of how it's how it's written in the page. So sometimes that can be a little bit of a hangout, and that's because I'm using the digraph. If you use the graph version, you don't get into that headache. Oh, geez. Just a second. I thought I can put myself on Do Not Disturb. Okay, so there are core concepts in a dot document. There's the graph and subgraphs. So that's the overarching encapsulation of the graph object. Within that, there are nodes, and the node is the actual objects that we're talking about connecting, and the edges are those connections. And then we can apply attributes. There are different attributes you can apply to graphs, attributes you can apply to nodes, and attributes that you can apply to edges. So we'll take a look at each of these, and we'll start with graphs. And so a graph is like I mentioned, it's like the encapsulation of the entire document itself. So there's a digraph, and everything goes in one direction. A graph is directionless. Challenge with the graph version is it's directionless, and so you have to be very explicit on what direction your edges flow to. So, and your edges being your arrows, right? And then you can have a subgraph. So here I've got this labeled as graph. So this entire thing is the graph. And then you can have subgraphs. So this here is a graph all in and of itself. So the objects within this operate between themselves. I can operate across graphs as subgraphs, but the relationship between oval and hex are related to each other in a different way than the square or the record is, right? And then this cluster also and the subgraph is typically referred to as a cluster, and that's bounded by this line here. So the distinction is very small, but do know that there is a distinction between a subgraph and a cluster. I can create a subgraph and put an oval and a hex in it, and there won't be a line around it. Whereas if I create a cluster, a subgraph that's got a name of a cluster, it will have this line around it. So we've got graphs and we've got subgraphs. They hold objects, right? So what are those objects? Oh, this is an example, just a basic, simple example. So here's the digraph, test graph, and its label is example. And that's literally what we see is the label example. There's nothing else on this diagram except the label for the graphic. I'm going to take this now and we'll expand that as we talk through the rest of the other critical pieces. So there are nodes. So a node is your basic object that carries information that you want to share. And there are a number of main types. One of them is a shape. So this is a shape. Hex is a shape. Oval is a shape. Square is a shape. And then there are records. And this is a record. And each of these cells, I can refer to each of these cells within the record. And you can take this, and there's another type of record that is defined by an HTML table. So I can define an HTML table that becomes a record, and I can actually attach to different points within that HTML record. So record as it exists in this, using the record shape, you can't subdivide these sections. So in order to subdivide these sections, you need to go to a HTML table type. And then you can do user-defined table types or node types. And those are, so I can get up, oops, let's go back. I've got links to these guys. So the various different shapes, these are the myriad number of shapes that exist just in the basic form. And then here's some examples of user-defined shapes. So this is just a sample library that some user is given public access to see the different kinds of shapes. So he's defined these shapes with polygon edges and such. And so there's a lot of power in this. You can also define a node as an image. So if you were, for example, building out an architecture from Azure and you wanted to bring the actual Azure icons in, you can define that shape, the node, to be represented by that image. And that's not that difficult to do. And it's interesting. And then each of the nodes has a part. That's a misspelling. That should be ports. So the ports are defined by the compass direction. So this would be the north port, the east port, the south port, the west port, and in some renderings, there's actually northeast, northwest, etc. So there are ports on those nodes. And if we go and look at our example, here's our example diagram. Now I've put in a couple of nodes. And so the basic node shape is a circle that is bounded by the width of the label within it. So if this was a 1, it would be a circle. It's an oval because I put the label in it kind of stretches the circle out into an oval. Here, main, I defined that shape as a box. So I said, make it a box. And box is different than a square or different than a rectangle, because a box, again, is kind of like a circle. It expands horizontally and expands vertically depending on the size of the label. Whereas if I said this was a square and I put in the word rectangle, it would expand and there would be a lot of room at the top. If I was to say rectangle and I put the number 1 in it, it would have a lot of space on its sides. It doesn't, the rectangle just kind of sits. So by saying box, it grows and expands on its own based on the margins that are set by default, or you can control those margins. So that's an example of what a node code looks like. All right, so great. So now we've got a graph, we've got a name for that graph, and we've got 2 nodes in it. Now what? Let's put some value into this. And how we put value into this is we give it edges, and edges gives us information about where we are going from some place. So for example, this oval is going to this record and the square is going to this hex. And so the edges then connect the node objects, right? And the parts on an edge, there's the head, which is the arrow in this example. There's a tail. There's a label, which I don't have a label on this, but we'll see a label a little bit. And then there are shapes. There are shapes for the, oops, go back. Come on. And then again, they have shapes. So there are various different shapes that those edges can take. You can give them the heads different shapes. You can give the lines different shapes. So note that we have the ability to control what the edges themselves look like, which leads us to attributes. So with attributes, we can add more and more information, or pardon me, this is my sample code for edges. So here we've taken our example graph, we've got our 2 nodes, and now we have an edge connecting those 2. And this is the way this here, so the test with an arrow to main, that's how we define in the code an edge. If this was a graph, instead of a digraph, this would be a double dash. And then in the attributes section, we would define what direction the arrowhead goes. And in this case, I've added a label. Here's the label that I was referring to before, and I've given it a label of exit. This label distance and label angle, those are all related to their attributes controlling how close this exit label is to the line. Now we can talk about attributes. So attributes are used for object enhancement. And there are attributes that apply to graphs, there are attributes that apply to nodes, and there are attributes that apply to edges. Some of them apply to everything. So for example, I can give my graph a background color. I can give my nodes a background color. I can't give my edges a background color because there's no background to the edge. But I can give the edge a color, and I can give my fonts a color. I can give my lines that define my graphs and my subgraphs colors. So there's ways to control and manage the attributes of your different objects within your graphic. And here is a list of various different attributes. You can see the list is quite extensive. You can control, for example, the head port. So if I wanted the head port to come out of the southeast corner of my square, I could say this line, make it come out of the southeast corner. If I wanted to say, so here's an example, this line is dashed. I said, make this line dashed. I said, make this line red. So there are a lot of things that you can do with the attributes and a lot of control. You can change fonts within your objects or within the whole graph. So the power is pretty extensive with attributes. And here now we've taken our sample diagram and I've added some attributes to it. And one of the things that I did here, for example, is I defined a node, what a basic node looks like to begin with. So I said, make it a rectangle, make it light blue, and make it filled. So the test, you notice there are no attributes on the test node, but it's blue and it's rectangle and it's filled, because that is the default. What I set this as node, I created a default setting for any node that I create. And then here on the main, I said, make it a box and make it light green. And so it's different than the default. And we talked about the attributes that I added here with the head label and the distance and label angle with the edge. So this is just an example of what it looks like to add attributes. Now comes the fun stuff. I'm going to give you a demonstration of various different graphs, and what I'm going to show you, how I'm going to show you this is Visual Studio. I don't use Visual Studio a lot, but I use it for my dot, because there's a great plugin that allows you to visualize what it is that you've actually coded. So this is an example of a graph that I created while watching a video. I was watching a video on the car hire, the rail controlled negotiations process. It's defined by the federal government. That Rail Inc. is kind of the overarching railroad company group, and they define a process to negotiate various different things. And so I was watching a video, and I just started a graph while I was watching the video of what the process looks like. And so this is an example of just not necessarily, it's not necessarily a data flow, but it's more of a process flow. So just watching the video, I was like, oh, okay, so this happens and this happens and this happens. You get to a dead deal, or you get to an agreement. Great. And so this is something that I did on the fly. You can see, oh, I didn't mean to do that. So I commented that out in my process, commented some other things because that wasn't exactly what I wanted it to look like. So here's an example. Come on. There we go. Here's an example of a process that I was working on to move some data from AWS RDS to GCP, Cloud SQL, Postgres. So this was an example of a process that, and so what we've got here is we've got a cluster. So here's our cluster for AWS. So that's bounded, and this is color is blue. It's bounded by blue, and within that I've got a cluster RDP. So this is my RDP cluster, and I've got my GCP cluster, which is here, and that's bounded by green. And inside there, I've got a cluster Cloud SQL. And within those, so here, for example, here's my master MySQL. So I defined my master MySQL node up here, and then I call it within my cluster. I said, hey, put my master MySQL in that cluster. I could just as well have defined, so if I go here and put in another node, I can say test SQL. Geez, and just, classic, if somebody's watching you type. So it automatically puts in that node with the default that I've styled it as up here. And the same thing happens here. Here's my Cloud SQL. I bounded it here with my purple, and then I created a node called Cloud SQL right here with a label. So that's another example. Come on. And why did they do that? So let's close that example. Let's close this one. Here's an example of a Google architecture document. So this is it. So here's was defined at the organizational, the folder level, and then a project, and then I defined the compute engine. And so this is an example of an architecture diagram that I created while watching a video on Google Architecture. Again, just on the fly. Here's this one we've looked at already. Here's a really large diagram defining a different process for bringing in raw data, ingesting it, and processing it through various different procedures. And oops. So I've got a subgraph here that's our raw sources. And here's our ingest procedure. Here's a database cluster, again, a subgraph, and each of these colors is a subgraph. We look at the code for this. You can see there's a number of subgraphs within each of these. So we can actually even nest subgraphs within subgraphs, right? And then these are the arrows, the edges. And what's I want to point out here is you can say, I want to point at multiple edges. My edge, I want to point at multiple objects, sorry. So this, for example, this set of data is actually going into 2 different objects. If we look at, there's another one. I thought there was another one in here. No, there isn't. Okay, I took that out. But you can also do the opposite. You can have multiple objects pointing to one object via a single node edge. I mean, you can see here I've set a tail port on a number of these. I set a dashed weight, a dashed style. So if we look here, I created a dash style on these edges. So again, can control a fair amount of that. So now, okay, so great. This is great, Chris. So that's awesome. So what if so here I have to click export to actually get this graph out. I can actually, with dot, I can actually export that graph into whatever format that I'd like. So if I say dot, and I want to output a PNG, and I'm going to use this, what did I call this? This change management. And I'm going to output this to example.png, and we'll call it example change management PNG. I can say, open this now, example. And there it is. That was generated that fast from that code. So you can see that that's fairly efficient. Well, what about if I'm in a Jupyter notebook? Can I do it in a Jupyter notebook? Yeah, you absolutely can. Of course you can. That's why I actually raised the question. So I've got, there's a module called Graphviz, which is the Graphviz implementation of the Graphviz drivers. And so I want to import the Graphviz module, and then I'm going to instantiate a graph. So I've created a digraph called dot, right? And wait, actually this one commented out. So I've created this dot, and I'm going to add some nodes to it. And then so I've created a node, King Arthur, Sir Bedivere, and Sir Lancelot, right? And now I'm going to create edges. I'm going to create an edge between A and B, an edge between A and L, and then I'm going to create another edge between B and L, but I want to put some attributes on it. And so in this case, I call it out as an edge on its own. So here, now I've added that edge. Great. So I haven't seen anything, right? So I'm just at this point trusting that this has happened, but I can look at the code. So, but with dot source, there's the code. If I take this code and I were to copy this and paste it into Visual Studio and do preview, it would show me exactly what I was expecting, which is this. So here, if I call the object that I created, it's going to show me the graph right within my Jupyter notebook. It's not going to output it until I tell it to render. So at this point, it's still being generated at runtime and only here in my Jupyter notebook. If I want to actually save that as part of my code base or create, print it out or email it to someone, have you, I'm going to render it. And I've set this right now to view as true. You can set this default. If I set that to view as true, it's going to actually generate it and it's going to open it up. So with my default PDF viewer, there it is. It's creating that object, that document, roundtable.gv.pdf, which is what I told it to call it. So a little bit more complex code. I've took this all in one cell now. I've got an edge, I've got a node, I've got an edge. I'm giving my graph rank direction. You know, here I'm not giving it rank direction. What rank direction means is it going to render from top to bottom? Is it going to render right to left? Is it going to render left to right? Or is it going to render bottom to top? And this gets to that question of what direction, right? And so this is saying left to right. And I've defined that here, right? So if I go and say instead, change this to TB, it's the other direction. It's vertically. Now, if I say RL, it points the other direction. So the code is generated, the directions is generated during runtime, and the actual nodes and the placement of the edges are generated at runtime. So I don't need to worry about what directions are my arrows. Actually, you do. It's one of the most, it is, if there's one frustrating thing, is that part, is getting the things to line up in a direction that you want them to be. So here's a more complex example using attributes. So I've defined that my base node shape is an arrow. I've created a couple of items, objects. I've given a color to one of them, given it a shape of an egg. I told it to be filled. Then I said, hey, now at this point, start making my objects be stars. So everything after this, then the default is star. And you can see that this is what's happened. This is how it got rendered. And this here, now notice this is a graph, right? So now here, these are all dashes. And so you notice there are no heads on my arrows. In order to have heads on my arrows, I would have to add attributes to my arrows to say where the head is, which one is the head end, which one is the tail end. So this is the difference between a digraph and a graph is this. So we can also generate subgraphs within our code, right? So here we go. There's a subgraph, right? And now, great, Chris. So what if I wanted to generate a ton of nodes, a ton of edges, all at once with code? So I've just created this simple function, and all it's going to do is it's going to take in a list of nodes as a dictionary, and it's going to take in a list of edges. And then it's going to generate a graph, generate those nodes, generate the edges, print out the source, and then return the graph. So what have I got in my dictionary, my list of dictionaries? Well, I've got the name of the node, I've got the label of the node, and I've got the shape of the node defined. So you could add whatever attributes you wanted to. This code would have to be a little more organized if I wanted to say, hey, sometimes I don't want to offer a shape, but I want to give a color or a style. So understand this is a very simple function for doing this. So there we go. Ta-da, here is code, a graph that was generated with, just passing in a list. So you can imagine then, if I've got code that's generating lists or dictionaries, I can take that code and actually turn it into a diagram. Or if I was to say that I have column definitions in a list, I could use that column definition to create nodes that connect those column definitions across the rest of the code. So this is, in conclusion, this is kind of the idea here, is to recognize that that you can use code to generate the diagram on the fly, and I can update my code. I can create it in Subversion. It's simple, it's efficient, and I find it's fairly precise and pretty useful. We'll go back to the PowerPoint, and I can go to my wrap up. I've got in the PowerPoint, there are a number of resources. Graphviz.org is they're the kind of the holders of the dot project now, and they wrote the Graphviz module, etc. So there's a lot of really useful information at graphviz.org. So we go there, you can see there's information about the language, how to use it in command line, different layout engines. So here's the different layout engines that you can use. Output formats, here's the different output formats. So there's lots of information here on this website, a lot of theory on theory on graphs and visualization, just a lot of useful information. This article here, this is kind of every time I have a question really on what I'm doing, this is the article I go back to. Most everything that I've learned from this article. It's super rich with examples. So for example, here's, how do you make an HTML-like label? Here's for an example, right, of making an HTML type record. So you can see now, instead of a record that looks like this, now you can have a record that's got structure to it. There's a concept called ranking and order. And so this is the example I go back to every time I have a question about ranking. You can see the code for this is here. And so you can see rank same. So software IS, configuration management, these are all going to be in the same place, the same directions. And that is right here. All of these four, it ranked the same. And so they're on the same line. And the entire graph then is restructured. As soon as you say rank same for these, the entire graph, it gets redesigned because you said these are at the bottom. These are assigned to each other. And then it's a super rich article. Definitely, if you're interested, definitely go check that article and read it. And then Lev suggested that I put in a gallery, and this is the gallery at Graph.io. You can see some of these graphs are pretty magical. I mean, look at this network map. I mean, it is so big. Look at all this data. But this data could all be generated. Imagine this, right? If you had all of this information on all of these nodes on this network map, you could create this on the fly with Python or what have you, right? So you could do it within code. And then lastly, who am I? I'm Chris von Rabenau. This is my LinkedIn. Feel free to reach out to me either there or directly via my email. I'd be happy to answer questions or talk dot or what have you. Is there any questions?
This was excellent. This was very interesting. Thank you.
Yep.
Yeah, really good stuff. Thanks, Chris.
Mm-hmm.
Well, Chris, I was thinking while you were talking that, I don't know, it reminded me of the pictograms of the ancient world. I don't know if somebody will look at our diagrams or digraphs 3,000 years from now, are they going to look at these like, these are the hieroglyphs of,
right?
21st century or something. I don't know. It's
Yeah, that's a great point. Yep.
yeah, even rendering them like, you know, in different directions and left to right or top to bottom. I think the Egyptians' hieroglyphs were kind of the same way. You could read them from different directions and stuff. So I kind of
That's something
made the
different if you
connection.
did. Yes.
Yeah.
Yeah, this the amazing stuff. I have one question. Is it any way we can write a workflow structure which will help to generate via code?
Yeah, so therein lies the magic, right? I believe it's possible. I have not put the energy into it. When I raised the conversation with my friend Paul, who taught me everything I know about Git and everything I know about Dot, he's probably forgot, you know, the classic line, he's probably forgotten more about functional programming than any of us will ever know. His response to me when I got all excited about that, it was like, Chris, let it go. It's easier just to write the code. but I think I believe that it could be possible if you were to write it correctly, that it could be possible to do that. Yes.
Okay, interesting. This one definitely be interesting to discover as well. But it's a great start. I mean, I wouldn't even imagine that.
Yeah.
Create workflow graphs via code. Fantastic. Thank you very much.
Yep.
Okay, I'm stopping the recording.